Traditional software engineering relies on strict binary logic, but when you apply that linear thinking to complex automation, you hit a dead end. To move faster, we must examine three specific architectural challenges that bypass standard algorithms. Today, most developers still spend dozens of hours manually coding basic API integrations or managing content uploads one at a time. This reliance on manual code creates a bottleneck. If every piece of digital output requires a human to trigger a script, the scale of your engine is limited by your own physical stamina. The solution is AI orchestration. Instead of writing rigid code for every interaction, we build autonomous engines that use LLMs to route and process data dynamically. Reaching a state of zero-touch automation requires moving beyond these linear scripts and changing how data actually flows between your tools. The first challenge is pure digital distribution. How do you deploy a database update across the entire web without a single human keystroke or manual data transfer? Traditional methods fail here because they usually require a person to export a file or manually click Run to move information from a database to a social platform. We solve this by implementing an autonomous trigger. As seen in this workflow, the moment a status in Notion switches to Approved, the database fires a webhook. That webhook contains the raw data and pushes it directly into an orchestration pipeline like Make.com, removing the need for manual data entry. By eliminating the manual input layer, you create a structural foundation where the system can initiate its own work. The next challenge requires a single agent to generate two distinct types of output from the same idea, simultaneously and without crossing wires. The system must produce a 280-character post for X, while also reformatting that same core insight into a professional, long-form post for LinkedIn. To handle this, we route the data through an N8N AI optimization engine. The raw data enters an AI agent node powered by Claude 3.5 Sonnet, which creates two parallel processing paths. The AI processes the instructions for both platforms at once, outputting tailored variants that match the specific tone and limits of each destination. N8N then sends this finalized copy to Make.com via an HTTP request, which acts as the multi-channel distribution router. This allows for split-second timing. Path A triggers an immediate post to X, while Path B holds the LinkedIn post for peak engagement hours. This divergent logic is what allows a single idea to fracture into high-performing content across multiple platforms at once. The third challenge is context. Standard large language models are inherently stateless. Most LLMs forget the user and the specific project details the moment you close the prompt. We overcome this by building an orchestration memory loop. Because this uses no-code tools to chain logic, you can build a persistent assistant from scratch in under 2 hours. By connecting the LLM to an external memory database, the engine reads and writes data in an infinite loop, maintaining chat context across sessions. Once established, you deploy a user interface on top of the stack to finalize the assistant's architecture. Finally, the system completes its own feedback loop. Make.com routes the live URLs back to Notion, automatically marking the status as published, so you can track the results. Bypassing statelessness transforms a temporary script into a permanent, aware digital entity. Writing every line of binary code from scratch is becoming obsolete. The modern approach relies on chaining deep AI logic with reliable multi-app routing. This schematic shows the functional result. A system where you build the logic once and let it run forever, scaling your ideas across the web on autopilot. Every manual task you perform is a bottleneck in your own engine. Stop just using AI tools and start building autonomous systems today.